All right, well, I'd like to welcome everyone to this evening's session on the topic of uniformitarianism, non-radiometric dating, and the age of the Earth. And this is a very important topic considering most dating techniques are non-radiometric in nature. So it's a very opportune time to be taking a look at this issue. We're also going to be looking at the underlying philosophy of all these dating techniques. And that's essentially called uniformitarianism, where all processes have occurred the same way over time. And then we'll talk about how this impacts the age of the Earth issue. So what we'd like to do tonight is take a look at a list of processes that are non-radiometric in nature, and we'll kind of itemize the maximum ranges of age that they if you use certain presuppositions that they would date a particular artifact to. Then we'll take a little bit more of a detailed look at the Earth's magnetic field from a creation perspective. Remember, we are here in this particular session, or in all these sessions, in the series as a whole, we're trying to understand what the creation model is. So we're not really interested in refuting evolution. We're not interested in what the evolutionary model might say. We're interested in what the creation model might say. And so we're looking at the creation model as understood to the man on the street. And then we're going to take a look at this idea of extrapolation. What is the penalty that one pays for extrapolating in the unobservable past? And I call this the devil on the pillion, the devil that's in the saddle, because the models that we come up with, we want to minimize the penalty that we have to pay. So let's take a look at the doctrine of uniformitarianism. And very often you'll see this kind of popular phrase used to describe what uniformitarianism means, that the present is the key to the past. And it's kind of a simplistic phrase, but what they mean when this phrase is used is that the processes that you and I observe today, whether it be mountain building, whether it be the amount of dust on the moon and how it builds up, that all these processes have taken place over from countless of years at the same rate. Okay? So that's essentially uniformitarianism in a very popular way. Roger Huikos, however, summarized the work of Lyell, and he did it by defining 4 bullet points. Lyell was a geologist in the 19th century. He wrote the famous book Principles of Geology, which formed the philosophical foundation for Darwin's origin of species. And in this work, he outlined the doctrine of uniformitarianism. Uniformity of law, the laws of nature are constant across time and space. Now, this actually is not a bad thing. You know, E is equal to mc squared is true here as it is true in Japan. So in space and time, these laws are the same. That's a nice way of looking at part of the doctrine of uniformitarianism. Then we have this uniformity of methodology. The appropriate hypotheses for explaining the geological past are those with analogy today. Okay, that's not too bad if not taken to extremes. So for an example, if we look at how quickly the strata of the Earth are formed, and we say, let's observe what we see today, and we'll extrapolate that in the unknown past, then we can use that rate that we see to determine how long it took for all these strata to form. Uniformity of kind. Past and present causes are all of the same kind, have the same energy, and produce the same effects. This is a more detailed way of saying essentially the same thing, that the rates at which things occur have occurred at the same rate over long periods of geologic time. And then finally, uniformity of degree. Geological circumstances have remained the same over time. So if we take an overview of these 4 bullet items from Huikos, They essentially say that in terms of geology, that geological processes have occurred in the same way in both kind and in both process. So that the way in which strata build up, that occurs essentially at the same rate over time. And so we can use these rates then to determine the age of things. So uniformitarianism in this way is the underlying assumption of most evolutionary models. Okay? And actually, creationists use these same presuppositions in certain areas. And it's not always wrong to do that. We, for an example, are living in an age that's essentially demarcated, defined by uniformitarianism. We don't see volcanoes and creating strata every day. We don't see strata rapidly occurring. We see them occurring very slowly, actually. So today we're living in a period of uniformity. So it's not necessarily all that bad. You just have to know when to apply it, right? So let's take a look, keeping in mind this idea of uniformity. The creation model of origins, and let's not forget what we're here for. We're here to articulate the creation model of origins. So the creation model of origins includes both uniformity and catastrophe, and we'll talk a little bit about this in a moment. Catastrophe, and this is part of the geological creation model, catastrophe formed the majority of the geologic column that you and I walk on every day. We'll talk a little bit about this too. Uniformity played a much smaller role. Okay, so that if we were to dig down and take out a column of material out of the geologic column and examine that, we would see the majority of those strata, the creation model would predict, formed through catastrophe. The majority of them formed through catastrophe as opposed to uniformity. Short periods of catastrophe, then, according to the creation model of origins, translates into large portions of the column, and periods of uniformity translate into very small pieces of the column. As I mentioned today, we're living in a period of uniformity right now. So let's take a look at what we have here. We have here at the bottom, we have creation week. Now, creation week was only literally 7 days, right? Actually, 6 days. 6 days worth of actual work being done. But in those 6 days, God created the entire antediluvian geologic column, which would have been miles thick, right? Okay. After creation week, we had 1,656 years of essentially uniformity. Nothing was going on geologically. Okay? So that would have created a very small part of the antediluvian geologic column. Okay, you might have had erosion from rivers and things like that. Very small part. Then we have the flood lasting a little bit more than a year, ripping up the antediluvian column down to a particular point, redepositing it, and forming a massive amount of the column, miles thick. Okay? So here we have a relatively short period of time creating the geologic column that you and I walk on every day. And then, of course, from the time of the flood, we have roughly 2,500 years now. 3,500 years. 3,800 years. Of a period of relative uniformity, producing a much smaller part of the column that we walk on today. When we look at the Grand Canyon in a couple of weeks, we'll see that that is a phenomenon that actually is post-flood. Okay, so there we'll see an example of something that took place in a period of uniformity, though it was caused by a catastrophe. So you can kind of see this idea now. Catastrophe forms the majority of the column. Uniformity forms a minimum amount of the column. That is essentially what the creation model of origins would conclude. Okay. Now, within creationism, there are three models. There's the old Earth model, and those who hold to this would argue that the Earth is more than 250,000 years. And that's kind of a silly statement because most old Earthers are actually, they hold to the same ages that most evolutionary apologists hold to. But they come to the text without exception with extra-biblical presuppositions. And in every case that I've been personally aware of, they bring these extra-biblical presuppositions to the biblical text and try to change the normative meaning of the biblical text. And we saw some of these things earlier in this series. The earth is old, therefore we must find time in Genesis somewhere, so the days in Genesis are long periods of geologic time. Or there must be a gap between Genesis 1:1 and 1:2. As we saw, the grammar doesn't allow that, but we must force it in there. And some, to avoid all the exegetical problems that there are with those two particular positions, the gap theory and the day-age theory, they put the gap before Genesis 1:1. Everything from Genesis 1:1 can be legitimately interpreted, and the problem that we face is all before Genesis 1:1. It's a very clever way. And so these are the old Earth presuppositions. And they hold to strict uniformitarianism, that uniformitarianism as a whole is the presupposition that we bring to the geologic and astrophysical models that imply great ages. Then we have what I call the mid-Earth model. This is anywhere between that the Earth is 10,000 to 250,000 years old. These guys also bring extra-biblical presuppositions to the discussion. An example of what is often brought to the table is the varv production. Varvs are layers that are created by seasonal draining that are related to glaciers, perhaps. And they occur so many times a year. Therefore, if you take the number of layers, then the Earth must be so old. And so they bring those presuppositions to the biblical text. Then we have the young Earth model, and the only presuppositions that typically young Earth creationists bring to the text are biblical presuppositions. That is, I'm coming to the text with the idea that the way in which you and I are to understand the text is using the same rules of grammar that it was written with and nothing else. So I don't come to the text with the presupposition that the earth is old, okay? And I allow the text to answer that question for me, using the same rules of grammar and syntax that the text was written with. So these are essentially the three models that creationists typically fall into. So having said that, let's take a look at some of the non-radiometric dating techniques that are used to date the Earth. Okay? We'll look at processes that do not include radioactivity. That's essentially what non-radiometric dating is. Any process that does not include radioactivity is a non-radiometric technique. And these typically fall into two categories, accumulation and mixing models. So you're looking at a particular type of material that's accumulating over the years, and you use that accumulation to determine the age of that deposition. And there are literally hundreds of processes that are non-radiometric in nature that show youthfulness of the Earth, according to Russell Humphreys. I would encourage you to read some of his material because he articulates and describes, I think, 250 at least processes, non-radiometric processes that show youth. But the ones that are used are all those that show antiquity. So I think we need to be aware of that. And these processes are biological, geological, and astrophysical. For a long time, there weren't many biological processes that creationists discussed that address the age of the Earth issue. But if you read some of the latest biological work, biologists are jumping on the bandwagon that the human body, for example, has to be young. Because when you look at mutation rates and its debilitating impact on the human body, if we're as old as a lot of folks want to claim, we should have a lot more mutations. Okay, these techniques are often used by creationists to attack the presupposition of uniformitarianism. And this is not an illegitimate method, because what is being done is we are using the doctrine of uniformitarianism to show that if it is used, it ends up contradicting itself. Okay, so it's kind of like proof by contradiction. Let's assume this to be true, and we find a problem. So given uniformitarianism, we ought to see such and such, but what we see really is this and that. So you use the idea of uniformitarianism, you look at a geological process, and you find out that it can't possibly work because the data doesn't support it. And we'll take a look at some of these. So let's take a look at some of the theory behind non-radiometric dating techniques. So let's first take a look at the accumulation model. Basically all we're saying is that material accumulates when the inputs are greater than the outputs. So that material there that's in the basin will slowly increase if you're putting more into the bucket than you're taking out. Okay, so that's called an accumulation model. If the input is less than the output, you're not putting in as much as you're taking out, then that material ought to decrease, okay, or dissipate. The age of the system is simply the amount of accrued material divided by the rate of accrual, and for sake of simplicity, it's generally assumed that we started with zero amount. Okay, so this is typically how the accumulation models work. You measure the rate at which they're all accumulating, you measure how fast or how much material is there, and you can determine the age of that particular system. Okay, so let's take a look at some of these guys. Helium in rocks, very often helium is being produced by uranium decaying. You know, if you remember when we looked at radiometric dating, we saw that uranium decays through alpha decay, right? And alpha decay is nothing more than an alpha particle shooting out of a uranium nucleus, right? Well, what is that alpha particle? That's nothing more than a helium atom missing its electrons. Okay, so as the alpha particle comes up toward the surface of the Earth, it captures electrons. It's now a wonderful helium atom, and it gets captured in the surface rocks of the Earth. So you measure the amount of helium that you have in this material, and you can determine how old the Earth is, right? Well, if you do that, according to the rate group, it looks according to their research that the Earth can't be much older than 6,000 years based on the amount of helium that is in the rocks and atmosphere. The remnants that are caused by supernovas doesn't look like the universe can be any more than 7,000 years. This research was done at the International Conference on Creationism. When you look at human history, 6,000 to 10,000 years. Short period comets, which we'll look at a little bit later in detail, 10,000 years roughly. The Earth's magnetic field, 10,000 years. So when you look at how the Earth's magnetic field is decaying, it doesn't look like it can be much older than 10,000 years. We'll look at that in more detail. Then continental erosion, 10 million years. Seafloor sediments, 12 million years. Crustal growth and volcanism, 34 million years. Ocean salt accumulation, 42 million years. And barred spiraled galaxies, no more than 500 million years. Now, barred spiral galaxies is a very interesting thing. I think everybody knows what a barred spiral galaxy is. It's a galaxy that has two straight arms coming out of the central mass with the spiral arms connected to that. Well, after essentially one revolution, you lose that barred nature of the galaxy, because all these stars are rotating at different speeds, and so what happens is that galaxy loses its barred shape after essentially one rotation. So the period of that galactic rotation, is essentially the ceiling at which the universe could be have been created, right? So that's 500 million years. Now you might say, oh my goodness, that's far more than the 6,000 to 10,000 years that the biblical text requires, right? But it's still far less than what evolution requires. That's the point, All of these will not allow evolution to occur because it's just not old enough. So let's take a look at two examples in a little bit of detail, and they're not too difficult, but they're important nonetheless. So let's take a look at ocean floor sediments. Sediments accumulate on the ocean floor through the world's rivers. So as the Mississippi River brings silt and sediment down, it's filling up the delta area, right? I'm sure a lot of people have been down there. We were on a cruise one time in New Orleans, and we could not launch from New Orleans because I guess the tide was too high. They had some kind of a line across the harbor, and the ship was too big; it couldn't get under the line. So we had to take off from another place in Mississippi. But the point being is that the Mississippi River is taking all this material to the ocean basin, and it's all accumulating. So all the oceans or rivers of the world are doing the same thing at different rates and different amounts. The total amount per year is about 24 billion metric tons. And according to the plate tectonic model, about 1 billion metric tons are being taken away from just the continental plates subsuming under each other. So as subduction occurs, this plate is taking with it about 1 billion metric tons a year. So if you want to know what the total accumulation per year is, it's about 23 billion metric tons a year. 24 minus 1 is 23 billion metric tons a year. The sediment amount is about 400 meters in depth worldwide, and so you can determine then how old this system ought to be, and it gives you about 12 million years. Okay? So if I use uniformitarianism, I come up with a maximum age of 12 million years as the Earth system. So that contradicts the idea that evolutionary theory requires billions of years. Now, this is not a problem for the creation model because the creation model includes the flood. The flood would have captured much material on the Earth, on the ocean basins, and we just don't know how much was there in the beginning. But that's a problem. That's a problem for, I think, non-creation models here. All right, let's take a look at short period comets. This is a favorite of mine because this is just a general interest, I think, is that short period comets are comets that have a period less than 200 years. So they make their way back to the Earth in less than 200 years. And you can probably all think about one very famous short period comet, Halley's Comet, or Halley's Comet. It comes around every 76 years. And if you notice, the orbit of these comets are very elliptical in nature. They're not remotely close to being spherical, at least the ones we're considering here. And they go out from the solar system, make their way back, and come around the sun. And generally speaking, they can lose up to 1% of their mass every time they come around the sun. A lot of comets are made up of ice, and so they lose a lot of their mass through the cosmic radiation and heat of the sun. Halley's Comet loses at about 0.12% per period. And so the fact that we know that, we can determine the maximum age of Halley's Comet. This is kind of fun. So we can take the fact that it appears every 76 years, divided by the amount of mass that it loses, and that'll give us a kind of a ceiling on how old Halley's Comet is. Well, let's do that here. It can't be any more than 76,000 years old. So is that long enough for the age, for life to evolve? And the answer would be, of course, no. But the point is that that shows that our solar system must be much younger than what our evolutionary models require. So let's take a look now at a little bit more detail, the Earth's magnetic field. This is one of the best examples that creationists have developed over the years. And what the magnetic field looks like, it looks like exactly what you see in front of you. It's called a dipole field. The magnetic lines of flux come down, they come out of the South Pole, and they turn around and go back in the North Pole. Okay? And that's what the primary field looks like. It's called a dipole field. There are other harmonics, if you will, of the field, but we're looking at the primary field here now. So all evolutionary, or I should say most, or generally speaking, evolutionary and old Earth creationary models, they typically use this concept of a dynamo to model the Earth's magnetic field. Well, how is the magnetic field generated of the Earth? Well, the model that they use is a dynamo, and essentially what a dynamo is where you're looking at, let's say, two different materials, and they have a relative rotation speed with respect to each other. So one's rotating faster than the other, and because of that difference, you generate a magnetic field. Okay, and so what you have is this rotation between the core and mantle that's causing this magnetic field to occur. So a dynamo is essentially a machine that creates a magnetic field. You can do this having a conductor that's moved through a magnetic field. If you have a bar magnet sometime in your home lab, if you're a homeschooler, you probably have all sorts of magnets at home. Take a wire, connect it to a meter, and just move that wire through a magnetic field, and you'll see the meter move, because it's generated that changing magnetic field that the wire is seeing is creating an electric current, and you're seeing that electric current in the wire through the meter. It's kind of a fun experiment. So that this is the type of model that is often used for models that require antiquity of the Earth. Well, Thomas Barnes in the late 60s and early 70s at the University of Texas at El Paso took the data that he had at the time for the strength of the magnetic field, and what he did was he curve fit. He did regression analysis and so on, and he curve fit a curve to the data itself, and what he found was an exponential curve, our famous exponential curve, best fit the data. So he used that model to come up with a model for the Earth's magnetic field. What he did was his model included a spherical current, a spherical electric current on the surface of the core of the Earth. So you and I are used to seeing currents that are in wires, right? Well, those electrons are from literally, the electrons from the negative side of the battery move on the surface of the wire to the positive side of the battery, right? In electronics, you're thinking of holes. You're thinking the other way around. But if you're looking at electron flow, you're looking at electrons flowing from the negative terminal of the battery through the wire to get to the positive. Okay? And so instead of using a wire, he's saying that this movement of electrons is on the sphere of the Earth's core. All this physics and so on was formulated by Horace Lamb back in the 18th century or 19th century. But the model that Barnes came up with, he rejected this idea that the Earth's magnetic field could flip. Okay? So his model did not include magnetic field reversals. Okay, that's a very important thing. And most of his work was published in the Creation Research Society in the early 70s. And in 1973 and revised in 1983, he published his entire work in a monograph that was published by the Institute for Creation Research. So that's a very worthwhile monograph to get. It's still being published, I believe. Here is what Barnes's model looked like. You have the spherical core that's going east to west. So if you take your fingers on your right hand and point them in the current, okay, your thumb will point in the direction of the magnetic flow of flux, of magnetic force lines, if you will. So the current's going east to west. The magnetic field then points downward out from the core, comes back up, and goes into the North Pole. So the magnetic force lines come out of the South Pole, come around, and go back in to the North Pole. Okay, so they're the magnetic flux lines. And this is Barnes' model. Based on this spherical current, you're generating a magnetic field that is that's primary field is a dipole field. So this is what he is stating. This is his model. Okay, so you have a spherical electric current on the surface of the Earth's core generating the magnetic field, but the electric current is slowly dying off, and the reason it's dying off is because of the resistance of the material of the Earth's core. Okay, so it starts at a high value, and with this exponential curve, it's slowly dying, just like your battery slowly dies off as the kids' toys continue to be played with, and a month later you need new batteries, right? And what he measured was that according to the data, that the half-life was about 1,400 years. So if you take the exponential curve and you work backwards from today's value, you go back 1,400 years, the strength of the magnetic field is twice what it is today. You go back another 1,400 years, it's 4 times as strong as it is today, and so on. That is the magnetic field. And this is what it looks like. So Barnes's model then, his creation model for the magnetic field of the Earth, what he argues is that when the fall occurred, the magnetic field began to decrease. Okay? And it began to decrease in this exponential way and down to the present day value. And the equation for that curve is you see there. M sub 0 is the value of the field when it started decaying. So that would be the value of the field according to Barnes' model at the fall. And the little k in the exponent there is the rate at which it decays. Okay, that's related to the half-life. So all of that forms this nice little curve that we see before us. So you can see that Barnes generated his model assuming that at the fall the magnetic field began to decay and that it decayed steadily until even today in an exponential fashion. Now what this exponential curve does is it tells us that it decayed very quickly in the beginning and then very slowly toward the end. So it's not decaying nearly as fast over time as it was right after the fall. All right. However, there are fundamental failures or weaknesses with Barnes' model. It's a very good model, but there's some things we need to add to it to make it even a better model. Yet I shall show you a more excellent way, kind of thing, as the Apostle Paul once said. He did not incorporate magnetic field reversals. This was a huge fundamental problem for the model. And yet, when you look at the field data, the evidence for field reversals is literally overwhelming. We'll look at some examples today. Well, to bring us up to date now, Russ Humphreys, physicist out of Sandia National Laboratories, in the 70s and 80s, started working on this. And what he did was he took Barnes's model and significantly expanded it, and he convinced the creation community as a whole that these magnetic field reversals did in fact take place. So he assumed that the data is correct. And what he did was he created a young Earth model that was based off of Barnes' model, but it also included the magnetic field reversals. So he improved these models, and he improved the model to include these field reversals. And he's used his model since then to predict the various planetary models and what their magnetic fields might be, and has been very successful. And the majority of his work has been done at the international conferences on creationism here, right in Pittsburgh, specifically in the 1986 and 1990 conferences. So, we have more than, we have much more than 200,000 samples of field reversals from the geologic record. And this would include archaeological pottery and artifacts where the magnetic moments of the material, as the archaeological items have been buried, they no longer agree with the sediment they find themselves in situ, and so that represents a field reversal. Also, at the Mid-Atlantic Ridge, as the lava comes out, the magma material comes out at the Mid-Atlantic Ridge, we can see reversals there. We'll look at that in a little bit more detail. That's kind of a fun one. And then these things called igneous intrusions. We'll take a look at that. These are very interesting and fun examples. So here we see the Mid-Atlantic Ridge. If you notice, it's a huge scar, and that comes down through the middle of the Atlantic Ocean, and essentially is a 40,000 mile scar that's around the Earth, and I think we've seen pictures of this many, many times. One of the things to note, though, is from the Mid-Atlantic Ridge, because it's a spherical scar or crack on the surface of the Earth, it also has these canyons that are perpendicular to the scar itself, to the crack itself, to the ridge itself. And the reason for those is because if you're going to crack on a spherical surface, you have to crack in this manner. Okay, so if you take a piece of cardboard and move it around a balloon or a kickball or something, you'll find that cardboard cracks like this. That's the same thing here. So in order for this crack to go on a sphere, it has to also move in that way. So we have a typical scar that you would expect to find on a three-dimensional spherical object. Now, in this trench here, the Mid-Atlantic Ridge, what we have is magma material coming from the middle of the ridge, and it flows outward, right? And what we've been able to do is we've been able to measure the magnetic moments of the molecules in this material, and we've found that as you go out from the ridge, you find that these moments reverse themselves. 180 degrees. Some point north, you go a little bit further, they all point south, go a little bit further, they point north again. So what that means is that as this material is moving out, it's molten material, it's hot. So the magnetic moments, the molecules are not lined up with the magnetic field of the Earth at that time. But as the material cools down, it will come to a temperature called the Curie point, and however these molecules are lined up, once it goes lower than the Curie point, those molecules will be photographed in that rock at that time, and will be forever there in that orientation, unless it's heated up again, and they will align themselves with the magnetic field at that time. So when that rock freezes, if you will, it goes beyond or below the Curie point, the magnetic or the molecules then are aligned with the magnetic field at that time. So as the field reverses and as this magnetic material moves out, it's going to cool in such a way that it's going to capture the direction of the magnetic field when that material reached the Curie point. And so we see this north-south progression as we move away from the mid-Atlantic ridge. And this is remarkable evidence that the Earth's magnetic field did in fact reverse in the past. So now Humphreys is using this data, and he's including this data in his model for the Earth's magnetic field from a creationist perspective. So let's take a look at now magnetic intrusions. What we see in the geologic record in the sedimentary layers, we'll see a magma intrusion into the sedimentary layers. And this magma is very hot. It intrudes itself into the sedimentary layers, and as it's there over time, heat dissipates from the magma to the surrounding sedimentary rocks. So what happens then is the part of the magma that's closest to the sedimentary rocks, it cools more quickly. Okay? So as this rock cools, once it hits the Curie point, whatever orientation those molecules are in, because they're lined up with the magnetic field of the Earth, they're frozen in that position, just like the mid-Atlantic ridge. But the rest of the intrusion is not frozen because it's still hot, right? So you see these stripes in this intrusion where the outer edge of this intrusion is at one orientation, and the middle of the intrusion is at another orientation. And that's more evidence for magnetic field reversals. This is a very interesting one. So how do you and I as creationists bring this idea into our model? And how do we explain such a thing? Well, according to Humphreys' model, he would argue then that during the flood, these reversals would have occurred due to catastrophic and transient events. The magnetic field of the Earth would have nicely decayed until the flood, and then it would have become erratic, reversing itself many times during the flood phenomena, and then eventually works its way up and then settles down to a steady state manner as it is today. Okay, so this is the curve that Humphreys is offering, where you see when the flood came, the field reversed itself many, many times due to the catastrophic transient behavior of the Earth's core and so on, and that explains the field reversals at the time. So we have to bring these reversals in to the creation model. So the geologic record that you and I walk on every day was laid down in a little over a year, right? So what we need to do is, if we want to be successful in creating our model, we have to come up with a way in which we can fit the majority, not necessarily all of them, but the majority or many of them into that flood year, right? So can we do that? Can the Earth reverse itself about 50 times, because that's how many field reversals that we observe in the geologic record, in that flood year? Okay? So, can we do it? Well, how is it done? This is Humphreys' model. Let's see here. So, whatever the model we come up with is, it must be able to incorporate 50 reversals in 1 year. And this is the model that Humphreys came up with. Humphreys' model includes the following. In the core the core is molten, with the exception of possibly the center. What Humphreys argues is that during the flood phenomena, the core became very chaotic and turbulent for various reasons. And what happened during the flood year and beyond was the little pieces, if you will, of the core being hot and viscous and so on, these pieces of the core moved toward the surface. But because they're hot and very active electromagnetically, they brought with them, they changed the magnetic field as they moved. Just like an electron in a wire. As that electron moves in the wire, it's bringing a magnetic field with it. It's creating a magnetic field. What is a magnetic field? Have you ever wondered? It's nothing more than a changing electric field, right? So, as these parcels moved from the center of the core to the surface of the core, it changed the magnetic field just by its very motion, just like an electron in a wire. So what this slide here shows is that the very first, we're going to be taking snapshots of this process that Humphreys has come up with. So if you look at this particular slide, those little circles with the blue dot in the middle, that means you're looking at the direction of the surface of the current. Okay, this is the current that's going around the surface of the Earth. Okay, that Barnes came up with, a spherical current. And because there's a little dot in the middle, that means you're looking at the arrow as it's coming right at between your eyes. Okay, so the current's coming out of the page, and it's creating then a magnetic field in this manner. Okay, so as these little parcels come out from the center of the core to the surface of the core, what happens is the current, it reverses the current in that localized area, okay? And it also then changes the local magnetic lines of force. Okay, so if you can imagine all these little parcels coming out, kind of bubbling up from the center to the surface. Here we have 3 of them on the one side, just as an example. Well, what's going to happen here is that the magnetic lines of flux around each little parcel, the ones that are touching each other are going to cancel out, right? So you have something that looks like this in the next stage. So you've got something now, you have the current in the core has now reversed itself. Now it's going in. So you're facing, you see the little circle with the X's in it. That means you're looking at the rear of the arrow. You're looking at the feathers of the arrow as it's going away from you, where before it was coming at you. So the current of the core has now reversed itself. And because it's reversed itself, so will the magnetic field reverse itself. Okay, so now notice how it's pointing. It's pointing actually in the opposite direction, as you'll see. Remember, remember that the magnetic field goes out in the South Pole and comes back into the North Pole, right? So, what have we found here? It's coming out of the North Pole and it's going in the South Pole. So when you kind of take a look at the sequence of what these parcels of hydrodynamic material are causing, it's actually causing a change in the current of the core, which is causing a change of the magnetic flux of the Earth, the magnetic field of the Earth. It's complicated, but that's essentially what's happening. Is that as these little parcels of hydromagnetic material move out, they actually reverse the field. So that's Humphreys' model. But the question is, if this model is true, can it account for at least or roughly 50 reversals in this flood year? Well, the magnetic field of the sun reverses every 11 years. I don't know if everybody knew that. But the sun actually reverses its field every 11 years. So every 22 years, it runs its whole gambit, right? So it's also proportional to the rotational speed of the Earth and Sun. So if you take the sun as an example, you take 11 years, which is one reversal, divide that by the rotational speed of the Earth, and multiply it by the sun rotational speed, and that should be equal to the Earth's reversal rate, right? Well, it turns out that the Earth could have, during the flood, reversed itself every 20 days. That means we need roughly 1,000 days to get the entire 50 years worth, 50 reversals. So about 2.7 years we need for the magnetic field to reverse itself 50 times. That's not bad. That actually falls right in line with what one would expect. So the creation model can be used to predict these reversals. And Humphrey's model, he has used this for other planetary planets in the solar system and has been very accurate. Not so much for the reversals, but for the strength of the magnetic field, for the magnetic fields of these planetary bodies. So it's not a bad model. So this is what Humphrey's model looks like then. It began to decay at the fall. Until the flood, you had these transient events occur, producing all these reversals, and after some time, the magnetic field settled down and began to decay like it normally did prior to the flood. So that is the Humphreys-Barnes model of the Earth's magnetic field, and it's been used to predict other planetary fields in a very accurate way. All right. There are some related topics to this which some people might be interested here. If the magnetic field of the Earth was stronger in the past, this has implications for us, doesn't it? Well, a stronger magnetic field in the past means that we're not being hit with cosmic radiation much, because the stronger the field, the more energy the cosmic radiation needs to get down to the surface of the Earth. So if the magnetic field is stronger in the past, we would expect to be hit with less radiation, less carcinogens, and therefore possibly a longer lifespan. There would be less carbon-14 production in the upper atmosphere. If you remember, when we looked at carbon-14, we found that carbon-14 was created by cosmic bombardment of nitrogen molecules and things like that in the upper atmosphere of the Earth, producing carbon-14, it eventually becoming radioactive CO2, animals eating it, and so on. And so what a stronger magnetic field in the past would imply is that there would be less carbon-14 produced in the past, therefore things would look older than they really are if you're going to use carbon-14 as a dating technique. So the creation model of origins predicts that carbon-14 would be making things look older than they really are. So that's kind of interesting. And creationists have been normalizing carbon-14 to where it's one of our best friends. All right, let's take a look at this idea of extrapolation. I've really toned this section down because I don't think people want to get into the mathematics of extrapolation, but it's one of the more interesting fields in mathematics. Anyway, extrapolation is where you have a bunch of data points, okay? And instead of trying to find a mathematical function or a curve that fits inside the points, you're looking for a curve that fits, based on these points, goes outside of the data that you have, okay? Now, there's a problem when you do that. When you're interpolating data, okay, you're looking for functions that are inside the data. The data itself is keeping you honest, okay, because you kind of know the boundaries just upon how the data fits. All right, so it's keeping you honest from a mathematical perspective. But when you go outside of the data, you no longer have that demon of honesty hanging over your head. So there's a mathematical quantity called the error term that you must show is bounded when you extrapolate. Okay? So this Q term, if you will, is a price that you pay for extrapolating outside of the data. So that when in all our origins model, whether it be creation or evolutionary, there's this process of extrapolation, going outside of the data. Now you may say, well, what do you mean, Bob? What do you mean going outside of the data? When I take, for example, you take the nuclear decay rates that we know are occurring today, and I extrapolate these rates into the unobserved past. That is extrapolation. I'm taking the data and I'm creating curves and I'm going outside of the data. Okay? That is what I'm talking about. So with that extrapolation process, there's an error term that I must show is bounded. So as I'm extrapolating further and further back, if my Q term, if my error term starts to explode, I know that it's not bounded, and I know that my model is absolutely terrible and I should reject it. Okay? That's this whole idea of extrapolation. So for all extrapolation processes, it must be shown that Q is bounded. All old Earth models fall prey to an unbounded Q. Q becomes so large in these cases that Q is bigger or disproportionately larger than the very dates that they want to measure. And so what is Q? It's essentially the measure of the mathematical price that you pay for the very process of extrapolation. Okay? The problem for all old Earth models is that they all require the extrapolation of unverified assumptions, such as constant process rates, knowing the initial amounts of what you have, over millions and billions of years of what? Unobserved time. Why do we have to make sure that Q is bounded? Because we have a model that's not scientific, is it? In this regard, no evolutionary model, no creationary model that requires extrapolation into the unobserved time can be viewed as scientific. Why? Because science requires observation. Now, that's not saying this is illegitimate, but what it's telling us is that you and I and every evolutionist on Earth must show that their Q, the Q of their model, is bounded, is well behaved. That's very important, and unfortunately, it has been virtually ignored. In 1975, I would highly recommend everybody getting this paper. It's a paper written by David Rodabaugh, formerly a mathematician at the University of Missouri at Columbia. He wrote the paper, "The Queen of Science," mathematics that is, "examines the King of Fools." And in this paper, he looks in a detailed way at this process of extrapolation, and he shows that all these old Earth models have a Q that are so unbelievably unbounded that they are larger than the dates they wish to measure. Disproportionately so. So if you're looking at something like, let's say, 10 billion years, 10 to the 10th, right? The error term that you're getting is 10 to the 34, 10 to the 45th, which is just a little bit more than 10 to the 10th, if I can use a figure of understatement. And so what Dr. Rodabaugh has shown is that the price that these models have to pay for extrapolation puts them bankrupt. So ultimately, all these models, or submodels, if you will, that require extrapolation into the unobserved past are bankrupt because they have not shown that their error term is bounded and well behaved. Okay? So that's a major problem, and you and I as creationists, as we create our own models, we have to be cognizant about our own cues. Okay? And that's why the younger the model, the better your cue will be. And that's exactly what he showed. He showed that the young Earth model has a much better Q than any of the old Earth models, whether it be a creation model or an evolutionary model. A wonderful paper. Everybody should get it. All right. Let's open it up for questions.